Good day to you. This is Galactic bringing you a presentation in cosmic geometry. We're on the geometry side now. We've explored the cosmos for over a year now and over 320 lectures. I hope you've had a good time following along with me on a discovery vector. That is why I made those 300 some lectures. Now we're going on to capitalize on the discoveries made here at A&E in the basis of science, the axiomatic basis of mathematics, and a new geometry with, believe it or not, a new number system. Well, it can't be new, because we cannot ever leave linear numbers. What's interesting, though, is nobody ever considered that linear numbers can be extended. Now, complex numbers use an imaginary component, as you know, which is the square root of -1, a very interesting thing to do, which adds a circular function to linear mathematics. But the key that nobody saw, the base of mathematics, and that's the fact that our numbers are linear. So I got it in my head. I really was only giving tours of the universe and explaining the things science has discovered in the last century. But in attempting to explain many of the things in the universe to a general listening audience, whoever might wish to know in a nutshell what we have discovered that you don't find in the news, the discoveries that you never hear about, well, they're the best ones. They're the ones you never hear about. All this stuff about the Big Bang, well, sure, it's interesting. And black holes, it's interesting. Gravity waves, sure. Higgs boson, why not? Bouncing universes, multiverses, wow. But the actual discoveries never get into the news. And this is actually what real scientists want, is the stuff that's just not in the news. I've attempted to explain why media science just gives you sawdust. The Big Bang is nonsense. Even if you're interested in it. It doesn't hold a candle to one photograph of one galaxy. You could study that for the rest of your life, in effect, because science branches out. You'll want to know about stars and all kinds. And then the Big Bang is just dead end. Just nothing but convoluted, non-interpretable mathematics about stuff that nobody knows anything about. That really is the way it is. But here at Galactic, we're interested in reality. We actually want to know these things. But that's what I was doing. But in an effort to explain the edge of the universe is really what got me. Because children ask this question right away. What's beyond the moon? What's beyond the stars? They're trying to see to the edge. You can remember doing this too. I certainly can. Oh, we talked about it for a long time as kids. And found out later by discussing this with each other, a poll that I initiated just to find out if my mates remembered doing this, talking about the edge of the universe. Oh, excuse these glasses. These are my reading glasses. Just notice the reflection. All right, so that's what I was doing, but now I'm at the forefront of science with a discovery sequence that unlocks physics, changes the basis of mathematics. Whoa, way far for the better. To use rational numbers in spherical space to get actual computations of actual things, instead of just drawing straight lines through spheres and pretending that that's going to work. Of course it doesn't work. That's why we have calculus. It's why we have sine and cosine. It's also why we have division by zero. And it's also why we have irrational and transcendental numbers, which I got into and went right to the top. I went right to John Conway, who should have a Nobel Prize, but he's dead now, so he'll never get one, because the Nobel Prize, which is something of a sham these days, is not given out to dead people. And in fact, Stockholm wanted to give Henrietta Leavitt, the discoverer of potential wisdom. Wise men have been waiting this for 2,000 years. We're trying to get into outer space with every cell in our bodies. The entire human race is programmed to go into outer space. We have human beings living in outer space right now on the International Space Station. Well, that's just uncreditably amazing, miraculous, beyond belief. But why are we in outer space? Well, there are two reasons. It's to have bombs, to have a military platform. You can check the history books, I'm not making that up. With the explosion of the Tsar bomb, human man-made explosion ever witnessed on Earth, that ended the nuclear arms race. Because the military just, once they start spending, they can't stop. We went into outer space. Russia has since collapsed and has no more military power, as they're attempting to demonstrate to the world in Ukraine. Russia is no more. Russia, it only has enough power now left on Earth to just barely tip the balance to keep NATO from overrunning the Middle East and taking over the oil fields in Iran and Arabia. The only thing that's really stopping that right now is the presence of Russia. So you should thank God, if you're a religious person, for Vladimir Putin, because he's single-handedly holding back the apocalypse, which is right around the corner anyway. So there's our bracketing information for why we're doing astronomy, is to get the hell out of here, okay? With our minds. We're blueprinted to do this. The rocket ships going into outer space are meaningless, except to people who are just trapped on Earth and just, wow! Well, I'm one of those. Only when I'm acting halfway between a monkey and a human, as the evolutionists tell us. But you have another part of you, which is given to you by heaven. And if you don't like that, you turn this off right now and go straight to hell without collecting anything. So what we're going to do today is stay on the bright side of the universe. We're going. We're going. That's all I did a year ago, or a year and a half ago now, is take people out to see the universe. Tours of the universe. Telling you, and that's why I'm on YouTube, basically. That was part of the plan, is eventually I'd be out on YouTube, and then I'd be able to show you stuff as we cruise. Perhaps in 3D, perhaps in 4D. Well, that's coming too. Oh, there's a good side to science. It's not all natural selection. You're monkeys! Everything that you do is because it helps you survive. You're a monkey. And the Big Bang. The universe is expanding! Listen to us! It is bullshit. Compared with reality, the discovery of the galaxies, by far the most beautiful things that the human eye has ever beheld. Literally can study it forever, but only if you're intelligent. Now, you are, but it has to do with your training and your disposition, and quite frankly, the amount of time you have. But we're all geniuses. We all have intelligence. We all can be our best, barring the usual injustices of the world like death, mental retardation, or going to a public American school. By the time you come out of that, you're retarded. You don't know anything. But the universe is still there. We're not shielded from reality. It's just that a screen is brought between you and reality. And the reason is you. If you're an adult, if you're mature, especially if you're a man, women are just exempt. They're going to heaven. Women, I don't see how women are not going to heaven. But men, no way are we eligible for heaven. We're monsters when we get together. But when you break off with your poker playing mates and your beer drinking mates and you're cheating on their wives' mates and locked into religion and politics, friends and family, and get the hell away from them and start acting like a real man with a real pair, you use your head. That's what we do here at Anagalactic. And you can tell I'm still just as human as ever. Oh, I'm not some pope in ivory tower. Now this is the way it's gonna be from now on. No, and I don't have tanks, or guns, or viruses. All I have is what the universe gives me to share. That's called wisdom. And that's what human beings are meant to do 95% of the time. It's why we have brains with minds. And this thing about consciousness, you're talking about God now. So get consciousness off the list in science. Science has nothing to do with consciousness. Science has to do with using your eyeballs and using your head to see real things and understand them. Maybe for the first time. But you cannot go wrong with astronomy. You want to play the lottery and be guaranteed to win, you start looking at the moon. You start looking at the moon, and you start training your children to stay up at night to look at the sky. Because that's how God teaches geometry. You don't get taught geometry by those little sticks, those Greek sticks. Draw a straight line, now make a hypotenuse. That's the Pythagorean theorem. That's shit compared with looking at the moon going around the earth. What's the shape of that thing? It's a sphere. What does it look like? It looks like a circle. What's the universe? It's a sphere. What does it look like? It looks flat. You have to use your mind to imagine that the universe is spherically infinite. And that's God again. When you say infinite, that's an undefined term. So's God. So, what we're going to do is now we're going to actually use the wisdom that's given us, the intellect that we have. You know enough geometry, and you know enough mathematics, if you're past the 3rd grade, to understand everything I'm going to show you. Over here, you see Geogebra. And now let's switch screens here. We're going to do a little work here. I'm going to show you how to use Geogebra from the ground up, without the gobbledygook, as Sabina Hussenfelder likes to say, without the gobbledygook. It doesn't matter what operating system you have. Click on Geogebra Classic. This is an online program. But one of the beautiful things about this free, absolutely free program is that you can do it entirely online. And now I just want to show you. So you have an empty area and then you have a graph area. Now down here you might think you want graphing. That's true, but let's look at the others. If you click on geometry, you get a different screen. Now you notice that the right window went away. Now look over here to the extreme right. You'll see what are sometimes called hamburgers. It's really 3 lines. And there are 2 of them. This one, which produces a small menu, and this one, which produces a larger menu. Now, you'll see you have file options, export options, editing options. Now, down here are some more important ones. But what you want is this one, perspectives. Now, watch what happens when I click it. We're back to where we were. So just to reiterate that, and when you click graphing, you're back to the beginning, and this is the default opening screen. Just to give you an idea of what you can do with this, you'll see over here, I'm highlighting things and clicking on them. Each one, as you click on it, will give you a description of what it does. And these are some amazingly powerful tools. I just want to give you a demo of what you can do really quickly. Click on the point tool. Down here, you have options. Now, whenever you're done with a tool, always click on this one. The one with the arrow where it says move, freehand shape. If you click on it now, nothing happens. But it gives you the ability to move things. You see I'm moving the entire graph. So when you click on the point tool, it gives you a list. If you click on the simplest one, it'll tell you what to do. And it already does. You'll see at the bottom of the screen, when I go down in the list, each one tells you what it does. Just click on it. So that was for the line. For the point, remember you click on this and now you're at the default. If you click on this and click on point, it tells you select a position or line or function or curve. Well, the last three don't make any sense. There's nothing there. So what we want is a position. Click anywhere. There's a point. Do it again. And now try to select 0, 0. It'll do it, and it'll tell you right here. The first point there, we can turn it off or turn it on. Turn it off or turn it on. If you want to delete it, click on these three dots and select delete. Now we have a center point. Well, that's very nice. What else can we do? Quite a few things, as you can see, but just going through this quickly, you could make a line, and it tells you what to do. Select 2 points or positions. We'll select one, and now you have to remember what to do next. Select it, but look what happens, Charlie. There you go. So let's just make a diagonal line. It knows what you're trying to do. You see it lock? It doesn't just smooth scroll through the diagonal. It's a very intelligent program. And now you create your second point, but you might not want it where the arrow is. Just move along and put it at 2, 2, and it'll do its best to guess what you want, because it's probably at some minuscule fraction in the vertical and horizontal. Click, and you got a line. And it tells you over here that that's what you have. There it is. You can turn it off or turn it on. Now it comes to the part I want to show you something we want to do. But first of all, if you click on A, you notice I forgot what I had said before. It just drew another line. Here's why. Up here, this is still highlighted. Remember I said you always have to go back after using a tool and click on this. But while we're here, you see it's not done. Press escape, and you got out. Now click on this. And click on it twice is what I do. Because when you click on it once, it gives you this very handy things you might be able to or want to do. But if you click on it twice, you're back to the default. If you make the same mistake again, watch, we'll make one more point. And now I'm talking to you, I forget what I'm doing, and I go over here, right here. Well, it just made another point. It's too late to press escape now, but you can go back over here, and now you're out of trouble. Always go back to this and click on it, so that by default you're in move mode. And I can prove that. You see it moves up and down. So that's very important. It's the one little nuisance. But if you make a point that you don't like, just go over here and find it. Where did it go? We turned it off. There it is. But what about C and D? We don't want those. We can turn them off. Or click here, delete. That's going to get rid of most of your nuisances. And just make a habit of always glancing up here and making sure that this is highlighted. But segment is what we want, and it tells you what to do. Select 1 point and select, and you see it knows what you're trying to do. But if you go to B, you don't have to narrow your eyes. Click on it, and it knows. You might want to change its color. If you have a segment, you can't tell the difference unless you actually can't. Well, no, you can't. It's set that way. But if you click on the item, this is the segment. It tells you, and it even has it. These are lines. All the lines you make will come under this heading. Your points will be here. If you want to do something with a segment, click on these 3 dots and get settings. Click on color. Now there's all kinds of things you can do. There's basic. You can show it or not show it. You can rename it, give it a different text. But you first are going to want to change the color. Mostly that's a very high priority thing. Click on light blue and click on X, and there's your segment. But you haven't, look up here, it still says segment. So click on A again, it thinks you want to do it again. Hit escape, and then go over, it defaults back now because you hit escape. But then click on this and click on it again. We're going to do that one more time, this time a circle. This is a point. This is for line things. This is for perpendicularity, parallelity, angles. It has tangents. Unbelievable stuff is in here. This is to make a polygon. This is what we're going to be using exclusively, along with anything to the left of it, lines, segments. We want circle. We'll get to the sphere later. This does 3D, and I'll show that to you later, but for now, we want the circle. So here are all the options for creating a circle. If you wanted an ellipse or parabola or hyperbola or just a general conic, you can do it that way. Here's all kinds of stuff here. Don't worry about it. We're going to make a circle. I'm going to select the top one, circle with a center through a point. Click on it. It tells you what to do. Select the center point, then a point on the circle. You might say a point on the circle. Watch. Select the center point. That's going to be 0, 0. And now move the mouse. We want this to be at a radius of 2. So I'm going to hope it guesses. It'll tell me over here. There's a point. There's the new point. See? 0, 2. Perfect. Let's make sure of that. Remember, we're still in circle creation mode. So if I click on A now, it's going to think that I want to make a circle. Hit escape. And now it defaults back to here. Be sure, I'm going to do that again. If you have circle highlighted and you create a circle, it's waiting for you to tell it to stop making circles. So when it shows this in blue up here at the top, I don't know if you can see the mouse. I don't think you can. Sorry, my software is a little outdated, I think. But click on this, and I always click on it twice. I'll do it again. Click once, click twice. Now you can do something else. It's kind of a nuisance. And now I want to just be sure this text tool is working. That actually startled me that it didn't work. Text, select your position, and now I don't see a cursor. Well, I'm going to type in something, and perhaps I just can't see it. Well, isn't that something? You could also put it as a latex formula for... I may have this locked. Whatever the case, it's not working. Okay, so the text tool is not... This is the online version, by the way. There may be something going on with my browser. But I've never seen this fail. Of course it would now that I'm presenting it to you as some infallible program. But you can trust me, millions of people use this program. It's freeware. It was developed in India by some genius who made this so kids could learn mathematics, algebra, and geometry in school. And then very graciously, I think, they made it freeware. Well, they want it to be popular because then the schools and other institutions want subscriptions. So that's how they make their money. But this is really generous, in my opinion. That's a pretty easy way to make a circle, isn't it? Now I'm going to show you now, oh, I almost made the same mistake. Watch. I'm going to try to drag this. No, it thinks I want to make another one of those. So click over here twice, and now it's in... Now you can select move, but it defaults to that. So if you click it, it's already at move. Whatever is at the top, like for point, if I just... It thinks that I want to make a point. In other words, the top one. So if you click here, it's move. So this means it's in move mode. And I want to show you, you use the mouse to dial with a scroll action, and you can get greater precision. And then you can click and drag to recenter it. Keep zooming. We're checking to make sure that 2,0 is actually at 2,0. And look at that granularity. Now here it starts to get hard to maneuver. Just get bigger, more and more precision. Yeah, it drew it right at 2,0. Then zoom down. There are shortcuts for just about anything, and now the circle comes back into perspective. I would say, just from this short demonstration, You might be fascinated with this. I hope so, because we're going to be using it for about the next indeterminate number of lectures. At least the next 3 lectures will be in Geogebra to show you this new geometry. But there's one thing that a lot of presenters, at least in the past, and my history teachers, they leave out of a presentation is how to get the hell out. In other words, how do I save my work? You don't want to lose your work. Well, theoretically, you would want to know how to save something. It's one of the first things you look for. Over here, there are these 2 hamburgers. This one gives you a menu. And this one above it gives you file operations. Click on File, and it expands and shows you your file operations. You can ignore anything that's down here because we want File. So this is correct. So what do we want to do? Save online? You can, but then you'll have to create a free account. We'll do that later. I've already done it. I don't use it. I usually use this on my machine with a desktop version, which is also freeware. Really remarkable, but the point is we don't want this. You always want this, if you're me. Download as. So click on that and select the top. Geogebra file. You see all these other options. These all have meaning. You may or may not know what they all mean. I certainly don't know what they all mean down here. I never heard of these bottom 3. But it kind of makes sense. I can guess. But the top one is what we want. A Geogebra file, that one that we can reopen. Double click in here and select your name, first, file, or some bogus name. And then save. It'll put a GGB extension. Click save, and it puts it in your download. That's where it is. On a Macintosh, it is very easy. It really is browser dependent how you get to this. You just access this file. However, if you double click it, I'll double click it just to show you. This can be done in this operating system. Double click. It's supposed to open it up in Geogebra. Obviously, it did not do that. So, again, you click on this hamburger over here. Actually, it opened up my Geogebra program, but it did not load the file. I checked with the Geogebra pros. There's a whole support group. All of this is free, and that's never been resolved. When you double click on this file extension, you're supposed to be able to have it associated with a program that opens it. That actually does not work, at least on my machine. But that's a minor annoyance, because if you want to save it, you click on the hamburger, download as, Geogebra file, double click, put in second test or whatever you want to call it, doesn't matter. And now, what I can do is show this in what's equivalent to the directory system. There it is. It's in downloads. And now, I know where it is. So I could like copy its address and open it up. And here's how you would open it. So now you know how to save it. Now you could close it. How do you close it? Well, this is a browser window. So all you have to do is click the little X to close it. If you're logged in, which you can do later if you want to have an account, so that when you go to save a file, you can save it online. If you click Save Online, it'll ask you to save it. Let's do that. Save this. Save. And for me it says Save Successfully because it knows who I am. Because I have an account. You can too, so you can do that. And you can come back and retrieve that. Here's how you do it. Click on the sandwich. Click on Open. It'll show you the stuff. Here's my new file. Save this. This is in my online account. This is not even stored on my machine. If you're not too paranoid, you could do that too. There's nothing to be paranoid about, I don't think, but of course you never know. But if you click this arrow up here, here it says local file. If you select this arrow above it, it goes right back where you were. Click the sandwich. Click Save Online. It'll ask you if you want to overwrite it, maybe. Oh dear, no it didn't. So let's let's go back there. Open. Okay, it just copied it again. So I could open that again if I want, but right here it says local file. And here I have a button. If I click over here on downloads, there it is, first file. So if it will open it, but only from within Geogebra. So I have to actually press upload, and this is an upload. Here it comes. And it just loaded that. I should select another one. But you get the idea. And now when you're done, you close it. I just think that it's miraculous. So that's been a brief introduction to Geogebra. In the next lecture, I'll be showing you inversive geometry and the split harmonic on the ring on the sphere. I hope you enjoy it. It's going to be very, very intensive, but you're going to be able to see what we're doing. That is the miracle and beauty of geometry. So I hope you enjoyed this presentation. That's 37 minutes. We'll be back with what I actually have goose flesh right now. That's how they say it in Ukraine. My wife would say goose flesh. I'm from California. I say goose bumps. I listened to it the way she said. I went, goose flesh is better. Bumps you don't need. Flesh, you might, especially if you're hungry, which I am. I have some soup here that's filling my nostrils. We'll be back with some real science. Fermi edge, I don't say cutting edge. Fermi edge science. This is real science. This is the top of the list. This is the top of the ladder. You made it. I don't want to get religious on you, but somebody up there likes you, Daddy-O, because what you're about to see in the next few lectures is going to change science, and you're going to be the first to know it. Welcome to Anagalactic. I think that I'm the happiest.